actually this was included in my video in magnetic circuit. So we have here magnetic circuit, okay. So we're asked to find the current I if that's is equals to 1.4 times 10 raised to negative 4 Weber. Okay? So how to solve for I? Okay, so of course it will involve there yung under circuital law. Okay, so medyo mabilis ang phasing ko dito kasi medyo alam ko na kasi yung mga values na dapat na lalabas. Okay, so how do we solve that? So unang-una, ang gagawin natin is i-area by area natin siya or section by section natin siya. Please bear in mind na mayroong mga tuldok yan dito. At yung mga tuldok na yan ay ibig sabihin nandun siya sa may center ng mga figures na yun. Okay? So without further ado, let's get started and continue with this sample problem. So tiratahin natin ito. Okay. So anong una natin gagawin dyan? So hanapin mo natin yung mga length ng mga channel. Okay? Or yung length ng mga kalisang lugar. So I want to start muna with the cast iron. Okay? So itong cast iron na to is itong mga part na to. So that for the length of the cast iron, so I'll number it as number 1. So for cast iron, so that would be, alam natin na si EF ay 2.5. So dalawang 2.5 yan. Okay, so consider natin yan. So that would be length of iron is equal to, okay, EF, so that's 2.5 inches. So ito, 2.5 din yan. Pero meron tayong ibabawas. So meron tayong 0.2 na air gap, so we'll go into the dot that. And then, itong ED ay channel din niya yan, so therefore we're going to consider this. So considering E to D, so that is 52 inches. So adding everything, okay, so that would still be inches pa rin. So that would be equal to 6.8, okay, inches. So converting that to meter, okay, so that would give us 0.173 meters. So, ito pa lang yung length ng iron. So, what would be our next step? So, hanapin natin ngayon yung cross-sectional area ng iron part. Okay, so how do you solve for the cross-sectional area of the iron part? So, that would be equal to 0.5 times 0.8. Okay, so paano nakuha yun? So, considering yung ano, so, ito is 0.8 ito, ikalas natin to, and alam natin na, okay, yung haba nun ay 0.5. Okay, isa-isay natin. So, alam natin na ito ay 0.8, itong part na to, yung pag ganon, alam natin na 0.8 yan. And then, considering ito, yung part na to, since ito at ito ay symmetrically, so sa drawing ko hindi na siya ganun nakasymmetric. But if you're going to look at the figure no sa may ating slide, ito at ito ay equal at alam natin na 0.5 din yan. So that would be 0.8 times 0.5. And now we're going to get the cross-sectional area of the iron. So that would be 0.8 inches multiplied by 0.5 inches. Okay. So that would give us, okay, 0.4 inches squared, and converting that to meter squared kasi yun ang kailangan natin kay Weber pag minultiply natin siya to find the flux density. Okay. So this would give us 0.254 times 10 raised to negative 3 meter squared. Okay. So meron tayong cross-sectional area ni iron. So what would be next? Okay. So let's now solve for the flux density B. So for the flux rather. Okay. So meron tayong flux density, sorry. So that would be equal to the flux over the area. Okay. So using the formula, flux is given as 1.4 times 10 raised to negative 4 Weber divided by our cross-sectional area of 0.254 times 10 raised to negative 3 meters squared. So that for our B, we will obtain the value of 0.54 Tesla. Okay. So medyo mabilis ang context kasi alam ko na yung mga values. Okay. And yung iba kasi, nandito sa my solution sheet ko dito sa my bandang right. Okay. So we now have here 0.54 Tesla. Next, we're going to solve for our H. So how do we solve for the H of iron? Okay. So by looking up dun sa may table of pH curves, makikita natin yan na ang H natin for iron is equal to 1850 So nakuha natin yung H, nakuha natin yung L. Which is yung mga essential elements natin pag nag-ampere circuital law tayo later to solve for our current. Okay. So ngayon, tapos na si iron. So hanap tayo ng another section na hindi pa natin susolve. For this particular problem, ang hindi pa natin susolve is yung part ni laminated steel, which is this one. So we're going to solve for this one first, okay, before we go to the other parts na kailangan natin mahanap muna kung ano ang kanyang H. Okay? So for laminated steel, so let's first find the length of the steel channel. Okay? So for the length of steel channel, we know that GH is also equal to ED, which is equal to 2 inches. And then consider this 2, yung pagdudugtong nitong dalawa. Okay, so FG and then EH. Sabi ko, nasa center may dudok yan. So therefore, ibig sabihin, that would be, itong channel na to is, meron siyang kalahati ng 0.5. So kalahati ng 0.5 is equal to 0.25. Since dalawa yan, so that would be 0.25 and another 0.25, which is equal to 5. Okay. And adding everything up would give us the length of the steel channel be equal to 6.35. So actually it's a conversion na. 5, so that is 2.5. I'm sorry. Or if that's converted to the meters per 2 meter unit, okay, so that would be 6.35. Times 10 raised to negative 2 meter. Yun pa lang sa may part na yun. Okay. So, nakuha na natin tong part na to. So, anong next? Same. Cross-sectional area ulit. So, cross-sectional area is equal to, okay. So, that's equal to so, ganun ulit. Okay. So, if we're going to solve for the cross-sectional area, okay, so that would give us, so let's try to so 2.5 times, okay. So the cross-sectional area of the steel, so I've also resolved that. So that would be 0.9, okay, times, okay, 0.258, okay. Or rather that's a conversion na. Sorry for that. So if you're going to solve for the cross-sectional area, doing the same process, but considering yung ano niya. So that would give us 0.238, or 232 rather, times 10 raised to negative 3 meters squared. And then if we're going to solve for the flux density of the steel, so that would be, so same lang yan. Bakit naging same yung flux? Yung flux niya ay pareho kasi, di ba sabi ko, yung magnetic circuit that behaves like a series circuit or parang conductor coupled lang yan. Ang nangyari lang yan, nagpalit-palit lang yung mga parameters. Reluctance, resistance, EMF, EH, flux, whatever. So ang flux nito, kumbaga, kung may ang flux, sabi also, di ba, ang current ay pag naka-series, pareho. So sa case na to, ang anong katumbas ni flux? Si flux ay ang current. So therefore, kung ano yung flux dito, yun din ang flux dito. Kaya mangyayari, ang gain ng steel ay simply pareho kay, medyo pareho siya ng konti kay iron. At dahil nag-iba lang ng konti doon sa ating cross-sectional area ng steel. Okay. So that would give us, okay, so dividing the two, so 0. Or 1.4 times 10 raised to negative 4 Weber divided by the cross-sectional area na obtain natin dito. So 0.232 times 10 raised to negative 3 meters squared. So kailangan natin, so So for this one, okay, we can obtain our B. So B here would then be equal to 0.6 Tesla. Okay? So now, so we have here 0.6 Tesla. Okay? So by using the table of H curve, okay, the H for steel would then be equal to 125 ampere turns per meter. Okay. So nakuha na natin yung E ni steel. Okay. Okay, yung H ni steel, may L na rin si steel. So how about yung sa may air gap? Ito. So that is simply 0.2 inches. Okay. 0.2 inches lang siya. Okay. So, pero alam natin na hindi kasama si magnetization curve, si air gap. So, what we're going to use relationship. So, gagamitin natin yung formula na B is equal to, okay. So, B is equal to mu H. Okay. So, gagamitin natin itong relationship na ito. Okay. So by using this relationship, we can transpose everything and then manipulate the equation such that we'll have the H of the gap be equal to, okay, the permeability of the space times our B of H. Alam natin yung B na to ay equal sa B ni iron, which is equal to 0.54 Tesla. And that would give us the value of 4.3 times 10 raised to negative 5 ampere turns per meter. Okay. May H na si steel, may H na si iron, may H na si air gap. Okay. May let na si air gap, may let na si iron, may let na si steel. Therefore, we can now apply Ampere's circuital law. So, by applying Ampere's circuital law, applying circuital law. So, ganun lang din yan. So, alam natin na sa node na to, yung pinaka-main source natin. So, that Ni minus L of iron, H of iron, minus L of steel, H of steel, minus L of the gap, H of the gap. So, transposing everything na to the right-hand side, so equal to 0, would give us magka-plus tong lahat. So, that Ni is equal to, okay, that of iron, so 0.173 meters. H of iron, that would be 1850 ampere turns per meter, minus L of steel, so 6.35 times 10 raised to negative 2 meter. Ampere turns is 125 ampere turns per meter. You still see that? Minus L of gap. So I forgot to convert this. So that's equal to, so hindi ko nilagay yung conversion yan. So conversion ng 0.2 is, eto na, lagay ko na lang dito. So that is 5.08 times 10 raised to negative 3 meters times eto. So 4.3. So actually it's not, so 4.3 times 10 raised to negative 5 ampere turns per meter. Kung mapapansin nyo, mas mahina yung sa may air gap kasi talaga, gap siya talaga eh. So multiply, so if we're going to solve everything, okay, itong mga to, i-add up lahat yan. So you'll obtain the value on the right hand side, so that Ni is equal to 2512 amps. So since na kailangan natin siya i-divide sa may number of turns, we have number of turns here equal to 150. So we're going to divide. So that I is equal to 2512 divided by 150. So that the answer would be 16.7 amperes. And we have now obtained the current na kinakailangan natin dito sa ating circuit. Okay. So is everything clear? Okay. So dito kaya nakuha ito kasi yung cross-sectional area is tinimes natin dun sa may stacking factor. Okay. So do you have any clarifications regards that one? Okay. So if in case na meron kayong clarifications, questions, okay, so don't hesitate to send me a private message and I'll be always there to answer your questions. So hope you're enjoying the modules. Happy studying. So I'm always here to aid you. So thank you for listening to this lecture.